Welcome to the video lecture series on NFA with epsilon to NFA conversion. This is a part of the area of computation. So first step in order to convert NFA with epsilon to NFA. So you are supposed to find the delta dash for every state and for every input. Okay. The first thing what we are going to do here is what is meant by delta dash. Say for example, I want to find delta dash. So delta dash for a comma a. Okay. So that is equivalent to. So this delta dash which is equivalent to. Again, it is equivalent to. You can just write epsilon closure. And epsilon closure inside that again you put delta here, again epsilon closure, and the state is actually a here, epsilon closure of a, and the input you are going to apply is called as small a. Okay, so this is called as finding the delta dash for a comma a. Okay, this is equivalent to, so you are supposed to apply for every state as well as for every input. Okay, and the next step is after computing everything, then the step number 2 is you are supposed to identify whether it's a final state. So when actually a state is called as final state. So if state qi, okay, if state qi reaches a final state. If state qi reaches a final state, then a final state with epsilon transition. Okay, so this is the important part. If the state called as qi is able to reach the final state with epsilon transition, then we can say that then qi is also final state. Okay, so these are the two steps which is pertinent to NFA with epsilon to NFA conversion. Now we will actually elaborate with a problem. So these things will be elaborated with a suitable problem. So first I will take a problem. For example, convert NFA with epsilon to NFA. Okay, so I will take a problem. Say for example, I take Q1 and I take Q2, and the final state is actually Q3. So I make an epsilon transition from Q1 to Q2, and Q2 to Q3 again I make an epsilon transition. In Q1 I just apply A, and in Q2 just I apply BB, and Q3 you don't have any transition for A and B. Okay, so we are supposed to convert this NFA with epsilon to NFA. So what is the step we are supposed to do? So the algorithm says that in the first step you are supposed to find delta dash for every state and for every input. Okay, so what is every state here? So we have 3 states here called as Q1, Q2 and Q3, and now I find delta dash. So delta dash, I take the first state called as Q1, and this first input I take A here. So it is equivalent to you just write epsilon closure. Okay, so now delta of, inside delta again epsilon closure. Okay, and what is the state here? The state is actually called as Q1. So Q1, and the input you are going to apply is called as A. Yes. Now, epsilon closure, outermost you have one epsilon closure, and after that you have delta, and after that you have epsilon closure. The innermost operation is epsilon closure. So you are supposed to evaluate this epsilon closure. First, epsilon closure of Q1. Epsilon closure of Q1 is Q1, Q2 and Q3. So that is equivalent to epsilon closure delta of an epsilon closure of Q1 is actually you have Q1 comma Q2 comma Q3, and the input you are going to apply is called as A. Okay, so this is equivalent to epsilon closure delta of, so you can apply Q1 comma A union delta of Q2 comma A union delta of Q3 comma A. Okay, so out of this three transitions I can only apply A in Q1. Okay, the rest of the states actually Q2 and Q3 I cannot apply A. Okay, because no transition exists for A in Q2 as well as in Q3. Okay, so when Q1 is applied in A, where it goes? Actually, when Q1, if you apply A, it comes to Q1 itself. So you will again get the answer called as Q1. So rest of the two values actually you will get pi here. So the answer is epsilon closure. I get Q1 union pi union pi. Okay. So you get Q1 as an answer because pi and pi actually it's negligible. So don't take into consideration. Now epsilon closure of Q1. So epsilon closure for Q1. Now you get Q1 comma Q2 comma Q3. Okay, so when actually A is applied in Q1, you get Q1 comma Q2 comma Q3. Now I have to apply the next input for the same state. So what is the next input for the same state? Next input is actually B. So delta dash Q1 comma B is equal to, so I write epsilon closure delta of epsilon closure, and the state you are applying is Q1 and the input is B here. So epsilon closure of Q1, you will get epsilon closure delta of Q1 comma Q2 comma Q3 comma B. Okay, so out of these three states you can only apply B in Q2. Okay, you cannot apply in Q1 as well as in Q3, so no transition exists, so you will get pi. When you apply B in Q2, so you get actually always Q2 here. So the answer is epsilon closure of Q2. So find the epsilon closure for Q2 is equivalent to Q2 comma Q3. So Q2 comma Q3 is the answer. So I applied to a state called as Q1 and Q1, A and B has been applied. Now you just take up Q2 state, okay, and apply both inputs called as A and B. Now delta dash of, so now delta dash of Q2 comma A is equal to epsilon closure delta of epsilon closure of Q2 comma A. Okay, so what is epsilon closure of Q2? So you will get epsilon closure delta of, so epsilon closure of Q2 is actually Q2 comma Q3. So Q2 comma Q3, and when you apply A here, so the possibilities you cannot apply A in both Q2 as well as Q3, so you will get pi. So epsilon closure of pi. So you again get the same answer called as pi. Okay, so no transition exists for Q2A. Now I go to the next one. So next one is delta dash of Q2 comma B. So delta dash of Q2 comma B, and you get epsilon closure of delta of epsilon closure Q2, and you apply B here. Okay, so epsilon closure of Q2 of B, so epsilon closure and delta of, what is epsilon closure of Q2? It is actually Q2 comma Q3, so I apply B here. Now the only possibility is you can apply B in Q2. Okay, so that's what the transition diagram states. Okay, when you apply B in Q2, you come to Q2, and Q3 you cannot apply B here. So the answer is Q2. So epsilon closure. So epsilon closure for Q2 is actually Q2 comma Q3. So So I have taken two inputs here, that is Q1 and Q2. I have applied both inputs and I have find delta dash here. So the last state is actually Q3 is left over here. So what is Q3? So delta dash of Q3 comma A and epsilon closure delta of, so epsilon closure of Q3 comma A. Now epsilon closure of Q3 is Q3. So epsilon closure outside you have epsilon closure delta of epsilon closure of Q3 is Q3, and if you apply A here, so A does not have any transition on Q3, so the answer is pi. So epsilon closure of phi is equal to pi A. Okay. Now I think the last state is delta dash of Q3 comma B. This also results in pi, because B also you cannot apply epsilon in Q3. Okay, so Q3 epsilon closure of Q3 is Q3 itself. Delta of epsilon closure of Q3 comma B. Okay, so when you just abbreviate epsilon closure of Q3, you will get the answer called as Q3. When you apply Q3 comma B, no transition exists, obviously the answer is pi. Okay, so epsilon closure of pi is equal to pi. Okay, now the job is done. Now you have to put all these things in a table, and then you have to draw the diagram. Now how to put all these things in a table? Listen carefully. So I have three sets of transitions here. One is the first state called as Q1. So first state Q1, you can just put Q1. The next is Q2, and the third is Q3. And you have two inputs here. The two inputs are A and B. So now put everything inside a transition table. Okay. Now in Q1 when A is applied, where it goes? So what's the transition states in delta dash of Q1 comma A? It actually goes to Q2, Q1, Q2, and Q3. Okay. So now I can just write it as it is. So it goes to Q1 comma Q2 comma Q3. So I have written Q1 comma Q2 comma Q3. Now in Q1 when I apply B, okay, where it goes? Now you just go and see delta dash Q1 comma B. Q1 comma B actually goes to Q2 comma Q3. So this one. So actually we will have to write here Q2 comma Q3. Now the next is in Q2 if A is applied. In Q2 if A is applied, where it goes? So now I just go to Q2 here. In Q2 if A is applied, it goes to pi. So just I write pi here. Okay. And next is when in Q2 if I apply B, where it goes? If I add B, it goes to. Now Q2 if I apply B, it goes to Q2 comma Q3. So this is the state here. So I just write Q2 comma Q3. Okay. So and the last actually Q3 does not have any kind of transition. So that's what the original transition states here. So in Q3 comma A go for pi here, and in Q3 comma B also you go for pi. So I just rewrite this pi and pi. Okay. Now I have to put draw this into a diagram, and see, as per the theorem, which is called as a final state here. So originally we have three states here. So we'll draw the diagram. So Q1, Q2, and Q3. Okay, obviously Q3 is going to be the final state. Now, and we will make Q1 as an initial state. Now you check with the diagram. When you check the diagram here, when you apply epsilon in Q1, whether it is able to reach Q3. Q3 is a final state. Yes, obviously. When epsilon is applied in Q1, it goes to Q2, and in turn again epsilon is applied in Q2, it is actually going to Q3. So subsequently, if you apply epsilon for subsequent states, actually it is going to Q3. Okay, it is going to final state. So obviously Q1 is also called as a final state, and in Q2, if I apply epsilon, it again goes to Q3. Okay, so what the theorem step number 2 says, in state Qi, if it reaches the final state by applying an epsilon transition, then Qi is also called as a final state. So in this case, when I apply in Q1 epsilon, it goes to Q2, from Q2 again it goes to Q3 by epsilon, so Q1 is a final state and Q2 is also a final state, since when epsilon is applied it goes to Q3. So now these three states are actually called as final states. Okay. So now we can just draw the diagram. So in Q1, if I apply A, it goes to Q1 itself, and it goes to Q2, and it also goes to Q3. And in Q2 or Q1, if I apply B, it goes to Q2. So comma B, it goes to Q2, and it also goes to Q3. So A comma B, I just right click. Now in Q2, A transition does not exist. In Q2, if I apply B, okay, it goes to Q3. So Q2, if I apply B, it goes to Q2 as well as it goes to Q3. So B transition is here. Okay. And for Q3 you don't have any transition, and this is called as a NFA without epsilon. So thanks for watching the video. Have a good day.